All right, so this is 4.1.2, and we're solving right triangles. And for the first part, we're solving right triangles for length, for a missing side. And this is when we use trig. So I'm just going to go and put SOHCAHTOA on the side. And we're just looking at examples. I'm not going over anything really new today. It's just examples of the kind of problems you're going to get. So the first one is the example number 3 in the book. So in the book, it's page 222, and it's example 3. So it says to solve for x, given that theta equals 42 degrees, and it gives a triangle. So here's theta, and it gives us the hypotenuse is 18, and the x is on the bottom. All right, so then since we know that theta is in the bottom right corner, across from that's the opposite, but there's nothing over there, so we don't want to use that piece. So the x is the adjacent side, and the 18 is across from 90, so it's the hypotenuse. So we're using adjacent and hypotenuse. That is going to be a over h, it's the cosine. So the cosine of theta, but we know that theta is 42 degrees. So the cosine of 42 equals x over 18. And you just make sure your calculator is in degree mode, not radians. And then you can calculate it. Before you calculate it, you have to get x by itself, right? So the 18 is in the denominator, and just like you would solve any other problem, to get it out, you multiply it by 18 to both sides. So you can type it in your calculator just like 18 cosine 42 degrees. Or you could say 18 times the cosine of 42 degrees, or you could put the 18 in parentheses. The calculator will accept all of the 3 of those forms. And it will tell you that 13.376 equals x. And it doesn't say what to round to, so we're just going to leave it.
Yeah, I did. Yeah, thank you.
All right, so there's a first basic example. You're just using trig and a given angle to solve for a missing side. Is there a question? Okay, so then the next is the inverse trig. And you use inverse trig to solve for a missing angle. To find a missing angle. Measure. Whatever. And this is the inverse. So I know that you've already gone over these. You have inverse of sine, which is sine to the -1 of theta. You may or may not know that could also be arc sine. It's just another way of saying it, arc sine. It's the same thing. I think the TI calculators have the button as sine inverse, but for example, my calculator has a sine, and it stands for arc sine, so it's just another name for it. Same thing, nothing changed. There's also the inverse of cosine, or COS to the -1 of theta, cosine inverse theta, or arc cosine. of theta. And then, of course, there's inverse tangent. Which is tan inverse theta or arctan of theta. So they mean the same thing. Inverse sine, arc sine, inverse cosine, arc cosine, and arctan. Whenever you use this, I'm going to do a quick example first. I don't know if you were shown like why you do the way you do it. So if you had, for example, sine of theta equals 2/3. I just picked an example. So if you wanted to solve for theta, I feel like you probably were just shown you just do the inverse. But the reason you're doing that is because to undo sine of theta, you do the inverse sine. So it's the inverse sine of the sine of theta equals the inverse sine of 2/3. So what I'm doing is I'm doing the operation of the inverse sine to both sides of the equation, just like you would any other function or equation to take the inverse. And then it cancels out, the inverse sine cancels out the sine, and that's why you have that theta equals the inverse sine of 2/3. So I'm pretty sure when you were taught the inverse trig in geometry, your geometry teacher just said sine theta equals 2/3, so theta equals inverse sine of 2/3.
What's theta again?
It's just an angle. It's just a missing angle. So I'm just showing you the in-between step that you're doing. You're just using the inverse sine to cancel out sine. And that's how you get to that operation.
So it's basically like algebra when you do one thing to one side and the same thing.
Yes. But when they taught it in geometry, they most likely didn't show you what you were doing. They just said to do this, right? So I just wanted to be clear of what you're actually doing whenever you're doing these is you're multiplying both sides by the inverse theta, and an inverse operation cancels out the original.
So basically what they showed us is that to get the sign of the other side, you had to put the inverse sign on it.
Yeah, they just took out the middle step and just said, you started with sine theta, but you want to know what theta is, so you do this,
Okay.
right?
And then you just
But this is, whenever you do this, this is what you're actually doing to get there. Okay, so that was just more of a side note. And then I have an example, which is example 5 in the book. That is on page 223, in case anyone would like to know that. This is given this triangle. And it shows theta over here. And it has an 11 on the top, and it has a 26 on the right-hand side. And it says to find theta.
Could theta technically just be represented by an x?
Yes, but when you're talking about an angle, you use this symbol.
In geometry, do we use theta?
Probably. You should have.
We really solve it.
Yeah, it's just a variable that represents an angle as a special variable. Okay, so we want to know what theta is. So what relationship of sides do we have? Which ratio do we have? So the first thing we do is go from theta across from it
Opposite and adjacent.
is the opposite. The one that's next to it is the adjacent. Opposite and adjacent, that's tangent. So the tangent of theta equals 26 over 11. But we want to know what theta is, not what the ratio is. So, like what we just did, we're multiplying both sides by the inverse tangent, which I'm not going to go through that step. I don't expect you to have to go through that step every time. So just theta equals the inverse tangent of 26 over 11. Right, so this is how they told you to do it in geometry, was just jump to the conclusion. I just wanted to show you what you're doing to get there.
Oh, okay.
But it's fine just to do it like this. Perfectly fine with that. And then if you calculate it, then theta equals 67.067 degrees. And so we're going to round that to 67 degrees. And I'm going to make a note that we're always going to round to the nearest degree.
So this is basically just finding the angles based off of the side.
Yeah.
Wait, go ahead. So, like with the calculator, you just put tangent. Yeah.
Oh, how I calculate? Yes, I just type in second tangent for the inverse tangent function. And then you'll put in the ratio of the sides. And always round to the nearest degree. That doesn't mean if you're solving for a side, you're going to like round to the nearest foot or whole number. Only with degrees, we're rounding to the nearest whole number. So only with the angles, not the sides.
It's torture.
All right, so another example. Now we have the word problems.
Wait, okay, sorry.
Okay.
I'm confused because I plugged that in and I got like 1.17
You're in radians then. You need to be in degrees.
degrees. How do I
It's
change-
mode, the mode button, and then go down to degrees and press enter. When you reset your TI calculator, it will always go to radians, and you'll have to change it to degrees before you start.
So mode degree.
Mode, and then just arrow down till you're on degrees and hit enter. All right, so then
Oh, I see.
next example is example 6 in the book. And it's on page 224.
That's so funny.
So this is the real world examples. And this is about an airplane. So the problem reads, a ground crew worker who is 6 feet tall is directing a plane on a runway. If the worker sights the plane at an angle of elevation of 32 degrees, what is the horizontal distance from the worker to the plane? And it gives a picture. It's on page 224. So I'm going to sketch the picture. I'm not writing out the whole problem. We're going to go over it together.
So it's already out.
It's really open. Whatever, close enough. And it shows the airplane. This is my airplane. I'm sure it's going to be great. That's not too bad. And here's the guy that is working there. He needs to be standing here.
That looks like a bird.
All right. And it shows that the distance from the plane to the ground is 150 feet. And it shows that this man is 6 feet tall. And it shows the angle I do need to draw his head there. Sorry. So his height is 6 feet, and to the ground is 150 feet. So I have this gap here of 6 feet. And then the angle of elevation, so remember from the horizontal looking up, that's the angle of elevation. The problem said that is 32 degrees. And it's asking what is the horizontal distance from the man to the airplane. So that's the distance on the ground. That's what we're looking for. So we have this 150 from the airplane to the ground, but his eyes are 6 feet above the ground. So we do need to subtract that distance right here from the 150. So that gives our triangle has a height of 144 feet.
You subtract the height.
The height of the man, because it is from the horizontal looking up. So it's from his eyes looking up. So there's 6 feet from his eyes to the ground.
Oh, you
but this 150 was from the airplane all the way to the ground. So I had to take away that 6 feet to get the height for the triangle to do the trig. All right, and now from the man, where the angle is of 32 degrees, across is the opposite, so this 144 is my opposite, and x is the adjacent. So we're looking at tangent of the angle, and the angle is 32 degrees, equals opposite over adjacent, so 144 over x. And before we can type it in the calculator, we have to get x by itself, right? For this one, I'm going to go through the steps of how we get there, and then after that, I'm okay with doing the short way. So since x is on the bottom, I'm going to multiply by x on both sides.
I didn't know if you could do that.
Yeah.
Yes.
Mine's on the bottom.
So now I have x tangent of 32 equals 144. But I want x by itself. So I'm going to divide it by the tangent of 32.
I remember that.
So those cancel, and so x equals 144 divided by the tangent of 32 degrees. And so like I just said a minute ago, I'm going to show you all the steps, which I just did. But in the future, if you see x on the bottom, you can just make these two trade places, and that's okay. You can just skip to that point. You could have tangent 32 equals 144 over x, and then skip to x equals 144 over tangent. And then we calculate it. So 144 divided by the tangent of 32. And make sure you're in degree mode first. So x equals 230? Yeah, 0.448 is what I have. Feet. And I don't know that it said to round to anything, so we're not going to worry about that right now.
Just be 230.
230.4. Okay. If you get an answer that doesn't make any sense, like 3, and you look at the picture, and that wouldn't make any sense, that he's only 3 feet away, and there's only an angle of 32 degrees. That would be a clue that you're probably in radians, and then check the mode on your calculator, go to degrees, and then try again, and then it should make sense.
Does the degree mode affect like other math, or is it just like only applicable? Like
It should be fine. I don't think it's going to bother anything else. I don't want to say having it in degree mode won't affect anything else that you do on your calculator, because the calculator can do lots of things.
yeah,
But
anything that we're doing.
it should be fine. But we will be working with radians later,
Yeah.
so
What?
you just need to make sure it's set to whatever you're working on that day.
Okay. So what does radians mean?
Well, that's what we're getting to next week.
Okay.
It's just a different way of looking at angles. All right, so then the other one, the last example today is example 7 from the book, and that's on page 225, and it's talking about a hot air balloon. So it says a hot air balloon that is moving above a neighborhood has an angle of depression of 28 degrees to one house and 52 degrees to a house down the street. If the height of the balloon is 650 feet, estimate the distance between the two houses. So starting with like a picture, here's my balloon.
Your art skills are
I know, I'm an amazing artist. But you know what, it works. It's good enough. And I have a house here. And I have a house here. Because there's two houses down the street from each other. And this is my right angle. I want to know the distance between the two houses. That's what I'm looking for. I'm going to call it D for my distance. Let's see, what else did I have? 650 feet to the ground. And it also told me the angle of depression to one house is 28 degrees, and the angle of depression to the other house is 52 degrees. So from the balloon, we need a horizontal line. And then we can do the angle of depression going down from the horizontal, so you're in the balloon looking down. So from the horizontal looking down to the first house, angle of depression. That's what I'm explaining. It's from the horizontal looking down is the angle of depression. If he was looking up, it would be an angle of elevation. It's just telling you where the angle is. From the horizontal going down is depression. And it said 32 degrees. So from the horizontal going down, the line of sight is 32 degrees. And to the first house, and then to the second house, from the same horizontal looking down, is 52 degrees. So I have two angles of depression. And now I want to figure out the distance D. All right, so if you had Coach Bala in geometry, he used a phrase, the same one I used in geometry also when teaching, is Z angles are Z same. And it was for alternate interior angles are congruent, is the actual postulate. But you have the Z shape for parallel lines. So this line is parallel to this line. The ground is parallel to the horizontal. If you have a transversal that connects the parallel lines, the alternate interior angles are congruent. His shortcut to that was Z angles are Z same, because it always makes a Z. So I can translate this 32 degrees to the alternate interior position right here is also going to be 32 degrees. And then I'll have a right triangle that I can use. So this 32 is also right here as 32. And the other one, the 52, if I do it my Z here, but use this transversal, that means that this angle is going to be 52 degrees. If you didn't want to move the angles and you wanted to move the triangle, you could just take this vertical distance and you could have moved it over here, because that would have been the same, and made this 650 and have an upside down triangle. That would work too. I'm not going to confuse my diagram by showing it two ways. I'm just going to stick with this method.
How do you know which one's 32 and 52?
From the horizontal, when you get to the first one, it's going to be the smaller one, 32. And then to get to the larger one, it's going to be the 52. All right, so now I have an angle and I have a side. So that's enough to use trig. So I need to figure out what my relationship is. I'll start with the 52 degrees on the inside. So if here at 52, 650 is the opposite. And I want to know the adjacent. Opposite and adjacent is tangent. So tangent of 52 degrees equals 650 over the adjacent, which I'll call that, let's call it x1. Okay, so I want to solve and the x is in the bottom. My shortcut when the x is in the bottom is just let them trade places. So x1 equals 650 divided by the tangent of 52 degrees. All right, so if I look at that, then x1 equals 507.8357. Do you have a question? All right, so I have that distance x1, and that is 507.8357, because we don't want to round till the end, right? So that gives me this distance, but I want the distance between them, so I still have to keep going. Next, well, what if I did the other one? is still 650 feet up in the air, but now my angle is 32. And that will give me my distance x2, which is going to be from the same starting point, but all the way to the second house. That's going to be what I'm going to call x2. So the tangent of the new angle, 32 degrees, equals 650 over x2. So the distance to x2, which is house 2, and I do the same thing. So x2 equals 650 divided by tangent of 32 degrees. And that gives me 1,222.472. All right, so this one is 1222.472. And I want to know the distance between them. So if I subtract, that will give me D. So then D equals x2 minus x1, or 1222.472 minus 507.8357. So my distance between the two houses gives me 714.636. And since the measurement was given in feet for 650, this is feet. Okay. All right, so your assignment today is page 227, numbers 27, 29, 42, 44, and numbers 58 through 68 even.
So it's just on the same page as the bottom part?
Yeah.
Okay.